So in the last video, we looked at fractions of a quantity. So we were looking at applying mostly multiplication procedures using fractions and some whole number. So as a quick recap, we had, let's say we had these four boxes and we wanted to find half of them. So we want to say essentially what's half of four, or essentially half lots of four. And we went in and we said, okay, well, we have half lots of four. And we saw that, well, okay, visually it's all right because we could visually identify essentially what a half is. But we found that this was essentially equivalent to the four divided by the reciprocal of this number. So essentially the number flipped over, the fraction flipped over, which we get 2 over 1, which is just 2, because 2 divided by 1 equals 2. And we eventually got our answer. Now, this is all well and good and not too bad to do when we take fractions of a whole number. But where it gets problematic is when we find fractions of a fraction. So we're doing fraction multiplication. So here's one example here. And we're going to represent this using fraction squares like I've done in the past. So we want to find what is half multiplied by a quarter. We essentially want what essentially a half lot is of a quarter. And what I'm going to do is I'm going to make a fraction square here. And this should give you, hopefully, a bit of an intuitive sort of understanding of what we mean when we take a fraction of a fraction, which is essentially what multiplying is. So we have our fraction square here, and we want to find half of a quarter, or vice versa. But let's go with this. We're looking for half lots of a quarter. So let's draw up our quarter, because that's what we're going to be dealing with. And we have here a quarter. Obviously not perfectly drawn, but we have 4 equal bits. 1, 2, 3, 4. And this is our quarter here. Now, we want to take half of 1 quarter. So let's draw this here. So we have 1 quarter here. And we want to take half of it. So we'll split this in half. Now, the actual portion we've shown here with our half multiplied by a quarter is just this bit here, isn't it? That got rid of everything, but that is just this bit here. Now, this isn't really kind of, we talked about this idea of fractions being in different languages sometimes, almost. They feel like different languages because what I'm representing here feels a bit different to everything else. Because here I've only got one of my 4 blocks split in half. But check this out. What we can do, well, if we split all of these blocks up into half, we now have how many? 1, 2, 3, 4, 5, 6, 7, 8 equal portions now. All of these ones here are the same size as the fraction we desire. This fraction, which is the product of a half and a 4, or half lots of a quarter. Not 4, from what I said before, sorry. So we can say this is 1 bit out of a total of 8. So we get that a half multiplied by a quarter gives us 1 over 8. Now, let me do another example and we'll see if we can find or pick up on a pattern that's happening here. So, we have another example. I want to find 2/3 of a quarter. 2/3 lots of a quarter. So, in quite a similar position to where we were before, but we're going to do the same thing here. We're going to draw another fraction square, and I find these just to be a good way to visualize these fractions we deal with. So, we're drawing our other fraction square here, and we can deal with this in this particular way. So, let's split it up into quarters, and I urge you, if you do these the other way around, have a play at home. Try first, for example, in this top example, try first splitting this fraction square into a half, then find a quarter of that. Or, split this into 2/3, then find a quarter of that. We can go either way with these. Now, I'll do it in a similar way to before, but I have my 4 quarters. So, let's find 2/3 of that. Now, we have 1, 2, 3 portions. I've split up my fraction square. I've split up my quarter into thirds. And I want to show 2/3 of that, which will be this particular portion here. Now, once again, this doesn't really tell me too much about the entire scope, the entire fraction, until we draw in our 4 quarters, all of these thirds here to show the total portion of, well, the essentially this shaded area, this green here, in proportion to the entire shape. So what have we broken this up into? We've broken this into 12ths now. And 2 of these make up our entire space of 12 blocks. So what have we found? We found that 2/3 of a quarter is 2 on top of 12. Now, before we wrap up, can we simplify this? We see top and bottom that 2 goes into our numerator 2 and our denominator of 12. So we can simplify now to 1/6. But wait, humor me for a minute. I've shown 1/6 here, and we know from what we've done, what we've talked about before, that this is an equivalent fraction. But that's not what I'm showing here. But can I? Let's have a look. And this might erase, so sorry in advance, but let's get rid of this. Let's get rid of this, and this. And I'll shade in the area that I had before. And lo and behold, I have shown 1/6 here. Now let's formalize what we've found from these 2 examples in a sort of one-size-fits-all approach to multiplying fractions. So take a look at the 2 examples and think of the answers we got. 1/8 and 2/12. By observing these, can you pick up on a pattern, a mathematical process that gave us the answer? Now, if you've paused and had a thought about it and come up with something on your own, that's great. But here I'm just going to formalize what we found. So we notice here to get 1/8, we multiplied both numerators. 1 times 1 gave us 1. And we multiplied the denominators, 2 by 4, and that gave us 8. Hence, 1/8. Now, let's see if we got the same in the second example. But we had 2 multiplying by 1. 2 by 1 gives us 2. And the denominators multiplied each other to give 12. And then we could simplify it to ultimately give us 1/6. So that is essentially the formal procedure that we undergo. So if you don't want to kind of draw fraction squares every time, which I kind of use them because they're a nice visual tool, but once we've at least understood the intuition, we've observed a pattern that when multiplying fractions, we multiply the numerators, and that gives us our final numerator, and we multiply the denominators, which gives us the final denominator. And we can simplify these as well, as we saw in our second example. Thanks, guys. I'll see you next time.